like it means nothing.
Hello, D25. Welcome to my talk on supercharging your security pipeline, or how you manage vulnerabilities in a multi-tool jungle. I was here last year talking about cloud security posture management, but this year I thought I'd take things one level higher, kind of looking at things from a higher perspective. I do believe cloud security posture management has its place in your security toolbox if you are deploying applications to the cloud, but now we're looking at things from a different perspective. I am Mikael Nilsson. I'm the product security lead for customer intelligence solutions at SAS. I've been at SAS for 15 years, and I've been in various different roles within the company, and I think for about 3 years I've been in this role. And I've seen an evolution of how we develop software at SAS. SAS is a fairly old company, and we've developed software for almost 5 decades. Customer intelligence has moved to a pure SaaS native solution, and we've evolved our development practices while doing that. Before I get started, I want to share a few words about SAS and what we do at SAS. Our vision at SAS is to be the most trustworthy data and AI partner that powers the world's decisions. And that's the only AI talk I'm going to do in this talk. Our mission is to provide knowledge in the moments that matter. And we do that by delivering the fastest, most productive, and trustworthy solutions. The solution I work with is called Customer Intelligence 360. It's a marketing solution designed to reimagine your marketing with trusted analytics and powerful decisioning. CI 360 is a hybrid multi-tenant software as a service solution. And what we mean by hybrid is that the solution includes both cloud-hosted software, which we host, and software that can be deployed on premises or where the customer's data may lie. Our kind of approach is to try to make decisions as close to the customer data as possible and move minimal amounts of data into our cloud. We have less responsibility of data that way. We follow DevSecOps methodologies and CI/CD to deliver features and functions to our customers at a very rapid pace. Customer Intelligence 360 really is built out of 3 different parts. We build or collect and identify and curate audiences regardless of the source. So we connect things from customer data stores wherever those may lie. And then we build journeys, we analyze, enhance, and orchestrate those journeys within our cloud infrastructure. And finally, we connect to customers through destinations and deliver messages to our customers and record responses. All right, enough product talk. In my talk today, I'm going to talk about our journey, how we've evolved in software development, and how our application security program has evolved with it. And I will talk about Defect Dojo, which is an open source, centralized vulnerability management solution. Now, I want to be clear, SAS is not affiliated with Defect Dojo. I'm not here to sell you software. And I'm not directly affiliated with Defect Dojo. But I like to use Defect Dojo as an example of centralized vulnerability management so that you can understand that concept. And I want to talk about the challenges we've had, the journey we took, so that you can have a reference point of how you might approach centralized vulnerability management. That's not saying that that's the right way, but it's at least a reference point. And I'll also share some thoughts on why I think this is important. And then finally, I'll talk about some lessons we've learned along the way and give you some tips if you want to take that same journey as we did. So let's start with our journey. Now, SAS has been developing software for almost 5 decades. And we used to, as many companies back in the day, use waterfall development with fairly infrequent releases of software which followed a predefined path and phases. With CI360, because we're building cloud-native software, we've moved into first monthly iterations of software where we developed our software and delivered updates on a monthly cadence. And we're now in continuous deployment. So any updates that we make, we ship into production. And we have heavy use of automation to test our software as it moves through the pipeline so that we can be sure that we don't break stuff as we deliver things to production. We go to production hundreds of times per month with our software. And our SLAs have never looked better. So that's good. So that's evolvement of how we develop our software. Now, obviously, the application security side of that has also had to evolve with that. With waterfall development, it's easy to have phase testing in your security program. In other words, you have a specific phase in your development lifecycle where you test your software, not only from a security perspective, but from a testing perspective overall. Now, that obviously doesn't really work really well when you go to a monthly iteration, because you have a very short time span to do testing if you're phasing it. So to be able to deliver monthly iterations of software, we had to develop scan automation. And that's where we kind of started making automation into the pipeline and delivering fix items to our developers automatically from the pipeline. Now, in continuous deployment, we had to go further. We had to automate things further so that not only are we pushing work to developers, but we're also resolving work for our developers. And we also had to take a more holistic look at things. So previously, we were pushing findings direct from a security tool to a developer. So a code scan finds something in the pipeline, it's a work item for the developer. Software composition analysis finds something, it's a work item for the developer. So direct. And they all look kind of different, and it was kind of clunky. So that's why we moved to centralized management. So why does all of that matter? Why does it matter at all to accelerate your development pipelines? Well, I'm sure you're well aware of how vulnerabilities and exploits have evolved over the years. This is from the most recent Mandiant report from late last year, where they've looked at the evolution of time to exploit. So how long does it take from a new vulnerability to be exploited? And that's reduced drastically over the years. In 2023, in the report that they looked at, it took an average of 5 days for a newly disclosed vulnerability to be exploited. Now, if we would still be doing waterfall development and releasing something every 6 months or something like that, that's clearly too slow. Obviously, you can do patching and things like that to remediate that, but it's even better if you can just deliver a fix into production, especially for software as a service. There's other reports, like the Verizon report, that kind of also say the same story. We need to be faster in our patching approach. And that's part of the reason why we need centralized vulnerability management. Some other stats from that thing. The Split between 0-day and end-day exploits is also getting worse. So we're getting more and more 0 days and less end days. And the difference between 0-day and end day is that 0 days are previously unknown vulnerabilities that just get announced and they're exploited. And end-day exploits are where the vulnerability gets disclosed either by the vendor when a patch is released, so it's a known vulnerability, and then it takes some time for an exploit to arrive. Mandiant also looked at end-day exploits, and I think this is important as well, because usually you can expect a patch for an end-day exploit. How long does it take for you to patch things? This is an important perspective of that. 12% of the end days that they looked at were exploited within 1 day of their release. 29% within 1 week, 56% within 1 month. So we need to get faster at fixing vulnerabilities. That is where centralized vulnerability plays a part, because that makes your developers focus on the things that really matter. Now, that's not the only thing. And I mentioned jungle in this title, so welcome to the jungle. What do I mean by jungle? Well, with the evolution of application security pipelines, you're probably running quite a few different tools within that pipeline to scan your code from various aspects, or your infrastructure, or so on. You may have static application scanning to scan your code. Maybe you're using SCA to scan your third-party libraries. Maybe you're deploying to the cloud and using CSPM, which I talked about last year, to look at your cloud configuration. And maybe you're doing DAST scanning, dynamic application security testing, once you've built that application and it's actually a web application, and then you're testing it. We're already here, we're starting to see overlap. So we have different tools that essentially produce the same finding from a different perspective. A dynamic application security testing tool will report vulnerabilities in a web application. And those could be attributed to an issue in your code. So maybe it's cross-site scripting or something like that, and it's coming from code that you wrote yourself. All right? Maybe it's not. Maybe it's a third-party library that you embedded in your software that's actually the source of that vulnerability. But now you're actually producing duplicate findings for the developer, and it gets harder for the developer to understand what they actually need to do to fix things. Let's not stop there, right? Maybe we have more tools in the stack. Maybe we have some specific tools that look at specific aspects of your security posture, like something that scans for embedded secrets in your code. Maybe you have a tool that does it better than your normal static scanner that scans for generic code faults. And maybe that secret scanner also scans your cloud to see if there's any embedded secrets in your cloud configuration. More overlap. Maybe you are doing containers. Maybe you have images. Maybe you're scanning those as well. Well, guess what? There's overlap. If you're embedding third-party libraries in your software and you're putting it in a container, well, guess what? Your container scanner is also going to report that library as being vulnerable. More overlap, more findings. Quite a bit of a jungle here. Maybe you have bug bounty programs. Maybe you're doing pen testing. The list just keeps going on. There's so many sources of these findings. You're guaranteed to have overlap. And it's going to be messy to try to figure out what are the valid findings. Well, let's not stop there. I at least like to try out new tools. Maybe we're replacing tools every now and then. Maybe there's commercial reasons to replace tools. How do you compare the output of those tools against each other? That's also challenging. Or maybe one part of your organization demands that you use a different tool. Maybe there's a regulatory requirement that for this environment over here, you need to run this specific tool because it ticks some conformities of regulation XYZ. Now, managing all of those vulnerabilities in each tool individually is a mess, and it's hard. And that's why we need centralized vulnerability management. So, enter Defect Dojo, or more generically, any ASPM solution. Defect Dojo is the tool that sits in between these tools and the developers. And it enables a few different things. And again, I'm not affiliated with Defect Dojo, but we use it. So I'll use that as a concept to explain what centralized vulnerability management is. So what is it? Defect Dojo is an open source application security posture management tool. It correlates findings across different security tools and brings them all together so that it's easier to triage them. It builds an inventory of applications. So as you're importing findings over there, it also builds you an inventory so that you have a better understanding of what applications are passing through your pipeline. And if you have tools that associate findings with endpoints, then you also get a catalog of endpoints that your applications have. It does automatic deduplication of findings. That's the really nice, cool part. So instead of working with multiple findings, you end up with a deduplicated finding. And it supports filtering, use of bulk tasks. So if you ever need to do manual triage of findings, you do them in one place, and you can do bulk tasks before you assign work to developers. All of that is powered by powerful APIs. So if you're more into scripting things, then you can certainly do it that way and script things rather than work through a UI. And there's reporting capabilities as well. You can get Defect Dojo out of GitHub. They have a public demo running, which I'll talk about it later. And they also have a licensed version, should you ever want to go there. But do your own due diligence. I'm not telling you to go buy Defect Dojo. There's plenty of tools out there that do the same thing. The power of Defect Dojo comes through its integrations. There's almost 200 different security tools that are natively supported by Defect Dojo. So the output formats that your various different tools put out can be ingested into Defect Dojo. It supports static application security testing tools, software composition, software bill of materials or SBOM producing tools, infrastructure scanning tools, and threat modeling, and even bug bounty programs. There's also generic formats available should none of those tick your box. So you can import more generic things like AWS security findings format files, or Cyclone DX files if you have something that produces those, or Serif files, which are quite universally supported by many of the static scanners. And if that's not enough, there's also generic findings imports. So you can actually produce your own JSON file if you have some very exotic tool that's not supported and import your findings that way. Okay, so I said I'd talk a bit more about how we do things so that you can have a perspective of that. This is how our security pipeline looks like. So we have a CI/CD scan pipeline, which is running automatically as developers commit code and create PRs in GitHub. We run SAST and SCA scanning, we run secret scanning, we run DAST scanning, and all of that produces their own set of findings automatically. In addition to that, we also scan our infrastructure. We're on AWS, we scan our images, we have IAST running, and we have CSPM running, and all that produces findings. In addition to that, we have interactive engagements, which are not automated, but we have a private bug bounty program that we run for our solution, and we do frequent external penetration testing. And those produce their own findings. And before, like I said, the previous version of this was, well, let's just take the findings and push them onto the developer's desk. You can imagine the developers weren't too happy about that decision. So that's why we went and implemented a central place for all these findings. We push all those findings into Defect Dojo so that we can do triage over there, we can deduplicate those findings, and we can have different perspectives of reporting depending on your role, and I'll talk about that as well. And once we're done over there, we push findings into Jira, and we didn't stop there, so it's not just push into Jira and then have developers do that. We're also active, so if a tool stops reporting a finding, it automatically resolves the Jira ticket. So if a developer fixed it, they commit, they do a PR, it's merged, scanner runs, it's no longer there, Jira ticket gone. The developer didn't even have to touch Jira to do this. And developers love not touching Jira, I've heard. We also have alerting capabilities, so we can, if we have a critical service that we've deemed critical that's open to the internet, and there's a critical vulnerability on it, we probably want someone to look at it right away. And we can do that through Defect Dojo as well. So we can alert the on-call team, hey, you've got a critical vulnerability, you better fix this right now. Now, in an optimal world, this would all be ready, and I'd be talking about the great experiences we've had with this. That's not exactly true. This is our future state. We're not quite there yet, but we're on that journey. So I'll talk a bit about our challenges that we had here. Well, first of all, we should have implemented Defect Dojo way earlier. We went through a few security tooling changes, and those were fairly painful for developers. Why? Because before Defect Dojo, our developers had to be familiar with the security tool, how it produces findings, how do the remediation paths look like in that tool, where do I find my service, whatever. And there was a fairly large developer impact when we switched tools underneath them, because they had to familiarize themselves with a new tool. Now, being smarter, I should have put in Defect Dojo way earlier and then shifted the tools. Some of the slowness also and confusion is that we're transitioning between collaboration and version control platforms. And that causes confusion because depending on which tool you're on, you might have slightly different security SLAs. Your remediation path may be different than other services. So that's our own personal pain point. We don't have a really good solution to that, except let's get to the new platform. And with 5 decades of development history, and a long-time Jira user, you guessed it, we've customized the hell out of Jira and to do various different things. And that was a blocker from a Defect Dojo standpoint. Defect Dojo has native Jira integration, bidirectional, but we can't use it. So we had to write scripts around that and do that. But the nice thing is, it's powered by APIs, so if you have anyone who knows a bit of scripting, it's a fairly easy thing to do. Okay. Next, I'll talk about experiences with Defect Dojo from various roles and various aspects. I'll describe how it looks to a developer at us, how the triage works, how it looks to a service owner, and how it looks from a manager perspective or executive perspective. And that's all within the same tool. So the developer experience really revolves around Jira usually. They don't necessarily need to touch Defect Dojo unless they really want to. The Jira ticket creation is automatic, and the resolution is also automatic. And the Jira tickets do include links to Dojo and the reporting security tools as well, should the developers have an interest to actually dig deeper. And if we can, we include remediation instructions within the ticket. That's either flowing from the tool, or we can use templates within Defect Dojo to add kind of a template version of how do you solve, let's say, a cross-site scripting issue or input sanitization issue. And we also track goal dates, so we can push goal dates out of Defect Dojo. This is when you should fix this by, because our SLA is XYZ for this criticality of a vulnerability. And let's look at that a bit closer. So we have a descriptive title. It tells you what type of issue, what severity, and what weakness. And then it tells the developer which service it belongs to, because we may have developers working on multiple different services, so that makes sense. And then we can push in labeling over there. That means something to us. It's a security issue, it sources Dojo, and it seems to relate to a component called Jetty server, and it relates to a specific CVE. And if we look lower, there's a direct link into Defect Dojo, which developers can use to see a bit more detail on that, and then we enrich the Jira ticket with some information. And on the bottom there, the developer can find which specific version has the issue. And we may have a fixed-in version there as well. This one didn't have one, or maybe I cut it off. So the developer will also know to which version they have to upgrade to resolve this issue. If they click through on the link, they'll see something like this. This is actually from the public Defect Dojo demo instance, so they have one running all the time. If you want to go and click around in things, that's perfectly fine. But this is a code scan result and how it looks in Defect Dojo and a finding. You can see it has a severity associated with it. It has an SLA. This one's inactive, actually, so this would actually not be a Jira ticket anymore. It would be resolved, and the Jira ticket would be closed, but it's still retained in Defect Dojo. So we actually get an audit trail as well of which findings we used to have open, and that's, of course, important. And then there's a description. There's a location here, which file they need to go to, and what line number they can find the issue in. From a triage perspective, there's a lot going on in Defect Dojo. This is a busy slide, I'm sorry. First of all, we have automatic assignments going on there. So you can see, oops, that's not what I meant to do, sorry. So you can see over there, I've got a Jira ticket associated, and Defect Dojo actually tells me which ticket is associated to the specific improper neutralization of special elements finding. And we have custom fields in Defect Dojo, which controls who gets tickets assigned. I sure don't want to be that guy. And yeah, filtering. So one of the really powerful features in Defect Dojo when you're doing triage is there's context-based filtering depending on what you're looking at. So if you're looking at products, you have a different set of filters that you can use to find what you need. And then you can do bulk tasks, and this is powerful as well. So you can bulk edit tasks as you're getting in findings and do that initial triage in a fairly nice fashion. And it's regardless of tool, right? It doesn't matter which tool inserted these findings. It's always the same user interface. So you don't have to figure out how does tool XYZ do this, and how can I resolve it in that tool. All right, so yeah, bulk tool, maybe I discovered these are false positive. I can just check a box and hit submit, and they're now gone. They're false positives reported by Defect Dojo. And I can also merge findings, and this is fairly typical with many security tools I've seen, especially in static scanning. Like, you get a stored XXS finding for a file, and then you have 100 of them in that same file, because the tool doesn't differentiate between sources and sinks. Some tools are better than others, but in cases like that, you can do a manual triage and then just join these as one issue. So I'm just going to send one Jira ticket to this developer to go and fix their stored XSS issue in that file, rather than 100 issues. From a service owner's perspective, service owners have a single pane of glass where they can see the status of their service. And if they have multiple developers working here, this is useful for them. They see how many vulnerabilities they currently have active on their service. Maybe they need some more detail. If they can't remember what their SLA was, it's there. Maybe they're doing ASVS scanning. That's all visible over there. They can also track their SLAs. So if they have multiple findings, they can see how they're tracking towards remediation and towards the SLAs. Really useful. And they can add alerting. So there's user-specific alerting in Defect Dojo, which you can add to see if there's issues. The manager view is an even higher view, and you get it in the same interface. So you can see the posture of your full stack of products that you put in to your application. You can view by source as well. And like I said, you can have custom SLAs based on the criticality of the service. You can use metadata to enrich your application library so that you know which service is internet-facing, which one is critical to you, and then base your SLAs on top of that. All right, last topic, outcomes and tips. And thanks for your attention to this lovely guy. It's not just because of Defect Dojo, but this grand evolution of us moving towards continuous deployment and accelerating our security pipeline means that we're solving things faster. Our mean time to resolution has gone way down because of all of these different changes that we've made. In addition to Defect Dojo, we've done other things as well, like enabled depend-bot auto merges and shifted things left a whole lot so that developers have security tools in their IDEs, but also kind of shifted everywhere. Typically, developers are not interested in their cloud security posture. That's an infrastructure thing. But since we're fastly developing things, we want to get those findings to our developers fast. That's why we're scanning our stuff further ahead. We use less developer resources. They spend less time in Jira clicking boxes and trying to close Jira tickets. And they only work on verified and triaged findings because of Defect Dojo. And finally, we have a much better situational awareness of our application security posture because we have that grand view where we gathered all the different vulnerabilities regardless of the source. We don't have to go in different tools and try to figure out what the posture is. Some final tips. If you're not centrally managing your vulnerabilities, I firmly believe you should. So get started now. One place to get started, if you just want to get familiar of what the heck this is, go to demo.defectdojo.org, use those credentials, and you're in. Next, if you really plan to use Defect Dojo, you need to give some thought on how you structure your organization in Defect Dojo. Defect Dojo organizes things in an kind of hierarchical organization. It starts with product types, then there's products. There's engagements, tests, findings, and endpoints. Product types for us are kind of a bundle of services that have maybe different policies applied or are done by different organizational entries in our organization. Products for us are services, microservices. Engagements are the type of tests, so SAST, SCA, whatever. Tests are the individual tests, and they produce findings. And if they're, for example, a dynamic application security test, those findings may be associated with specific endpoints. And finally, if you ever get a thought that, oh, I could use Jira to do this. This is awesome. And that something is not project management related, just don't do it. There's probably an actual tool that you can use for that thing. Like Jira isn't good for driving Formula 1 cars, for example. You wouldn't want to do that. Except they just did, but that's a different story. So on that bombshell, thank you for your attention. And if you have any questions or want to chat, I'll be at the Accenture stand or somewhere close by after this talk. So happy to connect with you. Thank you very much.